Hi, everyone. This is a video about solving systems of equations by substitution application problems. So application means these are word problems. And so what I want to do is give you an example and provide you how I approach these problems and what I do to help you. So this is asking you to write a system of equations to describe the situation below, solve using substitution, and fill in the blanks. All right, so let's go ahead and read this. All right, it says two tailors, Carly and Evelyn, sit down to do some embroidery. Carly can embroider 2 shirts per hour, and Evelyn can get through 5 shirts per hour. In addition, the tailors have previously finished some shirts. Carly has already completed 12 shirts, and Evelyn has completed 9 shirts. Carly and Evelyn decide to take a break when they have finished the same total number of shirts. How many shirts in total will each tailor have finished? How long will that take? Okay, so one of the first things that I do is I try to determine what my x value is and what my y value is. And I'm not asking like what the numbers are. I want to know what do they mean. Okay, now, in all of these problems, all right, for this specific one where we're solving systems by substitution, we're going to use y equals mx plus b, where y depends on x, okay? X is your independent variable, y is your dependent variable, all right? So what you have to ask is what depends on what? And what we have is that the number of shirts that Carly and Evelyn create or embroider depend on time. So we're going to have y be the number of shirts, and x is going to represent hours. Now, I want you to notice that when you look at the question here, all right, it says blank shirts, blank hours. You have to determine what depends on what, all right? So in this case, however long you're working on embroidery, that will depend on the number of shirts that are created, all right? So from that, we have the number of shirts and the number of hours. We're going to set up an equation for Carly, and we're going to set up an equation for Evelyn. All right? Now, in this scenario, we have a slope and a y-intercept for Carly, and a slope and a y-intercept for Evelyn. So what we have to do is go back to our reading, all right? And we have to think about Carly's rate of change. Let's look at Carly. So Carly can embroider 2 shirts per hour. That per hour tells me that we are dealing with slope. All right, so Carly's slope is 2. All right, the other thing is that Carly has already completed 12 shirts, meaning that that's her initial value. That's the y-intercept. So that's 12. Evelyn can get through 5 shirts per hour. So Evelyn's slope is 5. And Evelyn has already completed 9 shirts. So Evelyn's initial value is 9. So now we can set up 2 different equations. I can set up an equation for Carly. And I can set up the equation y is equal to 2x plus 12. And for Evelyn, I can set up y is equal to 5x plus 9. Now, these are my 2 equations. And what we have to do is we can now set these 2 equations equal to each other and use substitution to solve. So I'm going to take 2x plus 12 and substitute that into the y value of our other equation. So then we're going to get 2x plus 12 is equal to 5x plus 9. Now, what we can do from here is we can now solve this equation for x, all right? So I'm going to move this 2x over to both sides, all right? And we're gonna drop down the 12. 5x minus 2x gives us 3x plus 9. And then let's subtract 9 from both sides. So then that's going to give us 3 is equal to 3x. All right, we're going to divide both sides of this equation by 3. So then x is equal to 1. So x is equal to 1. Now what's our y value equal to? All right, so now I want to take 1 and substitute it into either of our original equations. It doesn't matter which ones we do, but that's what we got to do. I'm going to choose Carly's equation because our numbers are a little bit smaller. So if I plug that in, I'm going to do 2 times x. Instead of writing x, I'm going to write 1 and then plus 12. So y is equal to 2 plus 12. Y is equal to 14. So now, remember, y is the number of shirts. X is the number of hours. So while, yes, you do have this solution, 1 comma 14, those numbers have meaning. So you have to go back in and go, okay, I'm going to complete 14 shirts in 1 hour. And that's how you set up and solve a system like this. All right, on this next question, and this is going to be exactly like what we just did for the first question, but let's go ahead and read through it. Hanson and his mom are planting vegetables in their garden. Hanson has finished planting 4 rows of carrots so far and is planting new rows at a rate of 5 rows per hour. His mom has finished 8 rows of tomatoes and will continue to planting at 1 row per hour. Once the pair get to the point where they have finished the same number of rows, they will take a break and decide what to plant next. How long will that take? How many rows will they each have completed? All right, so again, let's come up with an x value and a y value. What do those mean? Now remember, we're going to write each of these as y equals mx plus b, and y depends on x. Now, one thing to consider here is that typically x is always your independent variable, but x is usually time. Okay, so if we're talking about blank hours, Hanson and his mom will have planted blank rows. That tells you what your 2 unknowns are. So we're going to have y be the number of rows. So there's a couple different ways of thinking about this. X is typically time. Y is the other one. The other thing to think about is that the number of rows that each of them plant depends on how long they work, okay? So now we're going to come up with 2 different equations here, all right? I'm going to write an equation for Hanson, and I'm going to write an equation for Mom. Now, because each of these are going to have a slope and a y-intercept, so m equals and b equals for each. So you have to think about, slope is your rate of change using the word per. Y-intercept is your initial value. What are you starting at, all right? So if we're looking at this, this one's a little bit different than what we just had read. It says that Hanson has finished planting 4 rows of carrots so far. So that's what Hanson is currently starting with. Hanson is currently starting with 4 rows. And he can plant rows at a rate of 5 rows per hour. Okay, so again, per. So those 2 pieces of information are super important, okay? And it's using those words to help you determine, okay, well, which one are you starting with? Which one's your rate of change? All right, the next one for Mom, his mom has finished 8 rows of tomatoes already, And we'll continue planting at 1 row per hour. So for mom, her slope is 1, because that's the word per, and she's already started with 8. All right, so it's really important now that we set up our equation for both Hansen and for mom. So for Hansen, we're going to do y equals 5x plus 4. And for mom, y is equal to 1x, which is just x, but I'm going to put the 1 there, plus 8. Now, both of these equations are in slope-intercept form, all right? So setting up our system isn't that bad. And again, what we're taking is I'm going to take 5x plus 4 and substitute it into the y value of our other equation. Basically, what we're going to do is we're going to set 5x plus 4 equal to 1x plus 8. And we can solve that equation now for x. So I'm going to subtract 1x from both sides. All right. That's going to leave us with 4x plus 4 is equal to 8. Subtract 4 from both sides. And we're going to get 4x equals 4. Divide by 4 on both sides, and we end up getting 1 again for x. Totally fine. Now, to solve our system, we have to now solve this equation for y. So I'm going to take 1, and I'm going to plug it into either one of our original equations. Again, it doesn't matter which one you choose, but I'm going to choose mom's equation because our coefficient is 1. All right, so if we wanted to plug that in, I'm going to choose this one. So y is equal to, in this case, 1 times 1. You don't really need to put the 1 there, but I'm just doing that just for, for you to see it, plus 8. Now, 1 times 1 is just 1, and then plus 8. So then 1 plus 8 is just 9. So that's our solution. So we have the point 1 comma 9. All right. So remember what x represents and what does y represent. X represents hours, so x is 1 hour. And they will have planted 9 rows of vegetables. All right. So that's how you would set up and solve that system.